Dear students, today we start 11th chemistry, hard water and soft water. Hard water and soft water. Okay. So we are taking that water. And the water we are taking that is H2O molecule, which is a bent in structure. And if we classify the water to hard and soft based on the leather forming ability of water. So we are taking here that is based on leather forming ability of water. Okay, based on leather forming, based on leather forming, okay, leather forming ability, based on leather forming ability of water with soap. So there is a formation of froth, you know that. So the froth is nothing but leather. So based on leather forming ability of water with the soap, water may be classified into two types. So we are saying that is water. Water may be classified into two types. One is soft water. What is that? Soft water. And another one, it is hard water. What is that? It is hard water. So, based on leather forming ability, we may classify water into soft water and hard water. Oh, listen, what do you mean by soft water? A soft water is one which is easily formed leather with soap. So, what do you mean by soft water? It will form leather easily. So, it forms leather or froth easily. So, it forms the leather easily, then it is called as soft water. So, we are taking that hard water. In a hard water, it do not forming a leather. So, it do not forms leather. Do not form leather. So, the water which do not form leather are called as hard water. The water which easily form water, leather, which is known as soft. If we analyze chemically why some water is easily formed, why some water, just a minute. Just a minute. There is some interruption. There already stored biology. Okay, so we are taking that the new one. So we are taking that is hard water and soft water. So we are taking hard water and soft water. water and soft water. Welcome, students. Here we may discuss about hard water and soft water and how we convert hard water to soft water and how will you remove the hardness and we may take how will you determine volumetrically and degree of hardness. So here we may take that is water. We are taking a water based on the ability forming lather. So we are taking based on lather forming ability, lather forming ability, lather forming ability of water with soap. So, based on lather forming ability of water with soap, lather forming ability of water with soap, water may be classified into two types. So, we are taking water, a normal water may be classified into two types. One is soft water, and another one hard water. Okay. Why we may classify water into soft and hard? Based on lather forming ability. What do you mean by lather forming? Lather forming means it is easily formed the froths with the soap. So here, based on the lather forming ability of water, we may classify the water into soft water and hard water. And here, the soft water is one, it forms the lather easily. It forms the lather easily. So, a soft water is one, forms lather easily. Forms lather easily, then we may call this soft. Yeah, hard water is one, it do not form lather easily. So, it do not forms lather easily. Then we may call this hard. Okay. Now, we may analyze chemically. Here, some of the salts are responsible for forming the lather. So, here we may take it in a hard water, the soluble salts. Okay, that is the soluble salts. Soluble salts are calcium and magnesium. Calcium and magnesium are responsible to form lather. Okay, and these salts, these soluble salts are free in the case of soft water. So, the hard water which contains the soluble salts, these are responsible for there is no formation of the lather. But the soluble salts are free. Okay, soluble salts. So, soluble salts are free in the case of soft water. So, it can easily form lather with soap. And you know that what do you mean by soap? We are taking that soap. What do you mean by soap? Listen, we are taking that is the soap is nothing but the sodium salts of fatty acids. Sodium salt are fatty acid. It's nothing but soap. So it is a soap, and here R represents more than 50. So the sodium salt of fatty acid is nothing but a soap. Sodium salt of fatty acid is nothing but a soap. Then what will happen in hard water? So in a hard water, what will happen? A soap is reacted with these soluble salts, that is calcium or magnesium. Calcium or magnesium. Suppose we are taking the calcium, then what will happen? Here it is converted into, that is calcium salts. So that here that is calcium salts. Calcium salts. So that here that is CaRCOO twice. CaRCOO twice. And with that is some other, that is Na plus, that will be removed. Na plus, that is removed. So we are taking that is 2 molecules, and here also that is 2 molecules of Na plus. So we are taking here, this is an insoluble soap. What is that? This is an insoluble soap. Insoluble soap. So, insoluble soap is formed with the calcium or magnesium salts which present in hard water, so that it cannot form leather. It cannot form leather. So, the hard water contains the soluble salt of calcium and the magnesium, or sometimes iron. And this calcium and the magnesium are reacted with soap, that is the sodium salt of fatty acid, then it will be formed insoluble soap. So if the soap is insoluble with water, then it cannot form the froth. It cannot form that froth. So depending upon the froth formation, hard water is further classified into, that is, hardness of water is further classified into, that is, a temporary hardness and a permanent hardness. So we are taking that is hardness of water. So what do you mean by hardness of water? The hard water do not form leather easily with soap, because the calcium ion reacted with the soap and the soap become insoluble. So to become insoluble. So we may take that the hardness of water. So the hardness of water we may classify into, that is, 2 types. So we are taking, that is hardness of water. Hardness of water. So hardness of water is classified into 2 types. One is the temporary hardness. What is that? Temporary hardness and the permanent hardness. So we are taking temporary hardness, temporary hardness, temporary hardness, and permanent hardness. Permanent hardness. So here we may take the temporary hardness, and the temporary hardness is due to calcium or magnesium bicarbonate. So we may take that the temporary hardness, and the temporary hardness is due to, it is due to calcium and magnesium salts, calcium and magnesium bicarbonates. Bicarbonates. carbonates. What is calcium bicarbonate? Is CaHCO3. HCO3 is nothing but bicarbonate. So that the valency of calcium is 2, so it is calcium carbonate. And magnesium carbonate. What is that? Here, that is magnesium bicarbonate. That is HCO twice. So, due to these salts, calcium bicarbonate and the magnesium bicarbonate presence in hot water, it will be produces temporary hardness. So, temporary hardness is produced due to bicarbonate. So, temporary hardness is otherwise known as carbonate hardness. What is that? Carbonate hardness. So, carbonate hardness. Why carbonate hardness? This is due to bicarbonates of calcium and magnesium. So here we may call this, that is carbonate hardness. Carbonate hardness. Now, if you are taking a permanent hardness, and the permanent hardness is due to calcium and magnesium salts of chloride and the sulfate. So we may take that. Here, that is permanent hardness. Permanent hardness is due to that is chlorides of calcium, that is calcium chloride and magnesium chlorides, and sulfates of calcium and magnesium. What is that? Calcium sulfate, that is CaSO4, and magnesium sulfate. Magnesium sulfate. So here there is no carbonate at all, so that we may call this the permanent hardness is otherwise known as non-carbonate hardness. What is that? Non-carbonate hardness. So what is that? Non-carbonate hardness and that carbonate hardness. So it is very simple. Due to presence of bicarbonates in water, the hardness is produced. Then we may call this carbonate hardness, and it is a temporary hardness. Why we may call this a temporary hardness? That means by boiling these temporary hardness of water, then these salts get deposited at the bottom, so that we can easily remove the temporary hardness. We can easily remove the temporary hardness, so that here the hardness of water is easily removed. So it is temporary hardness. But if you are taking a permanent hardness, by boiling, the hardness of water is not easily removed. Now we are using a permanent hardness. It will takes some other components, some chemicals will be added, then only we may remove the hardness of water, so that they are called as permanent. So, what are the chemicals which cause the temporary hardness and the permanent hardness? What are the chemicals cause temporary hardness? This is calcium bicarbonate and magnesium bicarbonate. And permanent hardness caused by calcium and magnesium chloride and calcium and magnesium sulfate. Calcium and magnesium sulfates. Now, water softening. How will you soften the water? So, we are taking the next topic, water softening. What do you mean by water softening? We want to remove the bicarbonate from water, and also we want to remove the calcium and the magnesium chlorides and the sulfates from water. So the removal of these substance from water, which is known as softening of water or water softening. So we are in the next, that is water softening. What is that? Water softening. So we are in water softening. Water softening. What do you mean by water softening? Removal of the chemicals. What are the chemicals? Calcium and magnesium bicarbonate and calcium and magnesium chlorides and calcium and magnesium sulfate. So that here the carbonate and the chlorides and the sulfates. Removal of these chemicals from water. Then what will happen? Here hard water. What do you mean by hard water? Which cannot easily produces lather or foam. Then it will become a soft water. What do you mean by soft water? It can easily produces a lather with soap. Then it is a soft water. So how will you do it? The water softening. There are two types of hardness. One is temporary hardness and the permanent hardness. So here we may take removal of calcium and magnesium salts from water, which is known as water softening, and there are two types of that. It is removal of temporary hardness and removal of permanent hardness. So the first one we are taking removal of temporary hardness. So what is that? Here that is removal of temporary hardness. Temporary hardness. Temporary hardness. So the removal of temporary hardness that will be done by two types. The first one we may take that is by boil. What is that? By boil. So the first method that is by boil. By boil. So the temporary hardness is due to the bicarbonates of calcium and the magnesium. So we will take that is the calcium bicarbonate and the magnesium bicarbonate. So what is the calcium bicarbonate? The formula CaHCO3. CaHCO3 twice. So it is calcium bicarbonate. And this calcium bicarbonate on boiling. And here the calcium bicarbonate is soluble. This is a soluble one. So the soluble salt, that is calcium bicarbonate, which is present in water, which causes the temporary hardness. Temporary hardness. Now the soluble salt on boiling we may get, that is calcium carbonate. What is that? That is calcium carbonate. That is CaCO3, and it is an insoluble precipitate. Insoluble precipitate. So here we may get an insoluble calcium carbonate, and that the product that is water and carbon dioxide. Carbon dioxide, which is ammonia. Now, you know that the upward aroma and the downward aroma in chemical reaction. What is the meaning of upward aroma? And it is a gas, so it will be liberated off. Then, what is the downward aroma? And the downward aroma represents the precipitation. What is that? Precipitation. So, calcium carbonate gets precipitated and settled down the bottom of the container. So, it can easily be removed off. It can easily be removed off so that the temporary hardness that will be removed. So, here the temporary hardness is caused by a soluble salt, calcium bicarbonate. While on boiling, what will happen? It will be get precipitated as calcium carbonate, and it is insoluble precipitate. So it will be filtered off. Will be filtered off so that the chemical which cause temporary hardness is removed as calcium carbonate, so that the hardness of water is removed. And the next one we may take the same name, that is magnesium bicarbonate. Magnesium bicarbonate. So what is magnesium bicarbonate? Here we are taking that is magnesium bicarbonate. That That is bicarbonate means HCO3. And it is also on heating or boiling. Heating or boiling. Now, what will happen? We will get it. That is magnesium carbonate. Magnesium carbonate. So, magnesium carbonate get precipitated, which is insoluble. Which is insoluble. So, here it is insoluble and form that is water and carbon dioxide as a byproduct. So, here magnesium carbonate is also an insoluble one. Sometimes what will happen in the case of magnesium carbonate is magnesium carbonate is further reacted with the water. Magnesium carbonate is further reacted with the water. So, magnesium carbonate is further reacted with the water, then it will be formed, that is magnesium hydroxide. Magnesium hydroxide, that is MgOH, magnesium hydroxide, MgOH twice, and that is carbon dioxide. Carbon dioxide, and this magnesium hydroxide is also insoluble. It is insoluble. So that here we may get a soluble salt of calcium and magnesium bicarbonate, which is converted into calcium carbonate and magnesium carbonate and magnesium hydroxide, which is insoluble, so that it will be precipitated off. So it is precipitated off, then it will be removed as filtration. Removed by filtration. So by boiling, temporary hardness is removed. And the next method, which is clad process. So we are taking the next method of removing hardness or temporary hardness of water. So we are taking the second method, that is clad process. What is that? Clad process. So in this clad process, what will be done? Here, in this clad process, we are adding washing soda. We are adding that is washing soda. So here, we are taking that lime. So you know that is washing soda. If you are adding a washing soda, then it is removal of temporary and also the permanent. Now, in this class process, we are taking that is lime. What is that? Lime. What is lime water? We are taking lime is nothing but calcium hydroxide. Calcium hydroxide is nothing but lime water. Quick lime, calcium oxide. So, here we are taking that lime. We are adding lime with the calcium or magnesium bicarbonate. Calcium or magnesium bicarbonate. Then we will get this calcium and the magnesium carbonate as a precipitate. Suppose we are taking here, what is that? We are taking calcium carbonate. So calcium bicarbonate, that is CaHCO3. Calcium bicarbonate is reacted with lime. Calcium bicarbonate is reacted with lime. So what is that lime? Here it is CaOH twice. That is lime water. What will happen? We are getting that is calcium carbonate. So 2 calcium is that. So 2 moles of calcium carbonate. 2 moles of calcium carbonate, and that is 2 moles of water. 2 moles of water, and we are already know that calcium carbonate is a precipitated. So the precipitate is removed off. Calcium carbonate is an insoluble precipitate, and the insoluble precipitate is removed off by filtration. So as the same way, if you are taking magnesium bicarbonate, you are taking magnesium bicarbonate also. So what is that magnesium bicarbonate? That is magnesium bicarbonate. That is bicarbonate. That is HCO3. So magnesium carbonate is reacted with lime. What is that? CaOH twice. CaOH twice. Then it will be from magnesium carbonate, an insoluble product. What is that? Magnesium carbonate. So magnesium carbonate and calcium carbonate. So here there is a formation of calcium carbonate also, and that is water molecule. So here is water molecule, and here calcium carbonate get precipitated, magnesium carbonate is also get precipitated, and the precipitated is removed off. The precipitate is removed off, so that the temporary hardness is removed by two methods. What are the two methods? One is boiling. One is boiling. So by boiling, the bicarbonate is converted into carbonates, that is insoluble carbonates. It will be removed off. Then the class process, we are adding the lime. What is lime? It is calcium hydroxide. Calcium hydroxide. By reading the calcium hydroxide, we may get calcium and magnesium carbonate, which is insoluble. So it will be filtered off. So that the temporary hardness that will be removed. And listen here, in this class process, we will get, it is the main calculated amount of calcium hydroxide is taken. So here it is only calculated amount. Calculated amount. So here only the calculated amount of calcium and calcium hydroxide is taken. Calcium hydroxide is taken. Then what will happen if we are using the excess calcium hydroxide? So listen, there is a note here. They may ask that goes in plant process, if the excess of calcium hydroxide is added, then what will happen? Listen, we are saying calcium hydroxide in excess. Excess of calcium hydroxide. And you know that calcium hydroxide absorbs carbon dioxide from atmosphere and become calcium bicarbonate. So that here we may get, that is calcium bicarbonate. Calcium bicarbonate. So again there is a formation of calcium bicarbonate. And the temporary hardness is due to this calcium bicarbonate, correct? So that this bicarbonate is converted into carbonate in plant process by adding calculated amount of calcium hydroxide. Calculated amount of calcium hydroxide. If we are taking the excess of calcium hydroxide, it absorbs atmospheric carbon dioxide and become the calcium bicarbonate, so that the temporary hardness cannot be removed by using excess of calcium hydroxide or lime. So that we are using calculated amount of calcium hydroxide. Calcium hydroxide. Okay. And the next we are doing removal of permanent parts. So we are doing removal of permanent parts. So the next topic we are doing is removal of permanent parts. Removal of permanent parts. How will you remove permanent parts? And What are the chemicals are responsible to cause the permanent? You know that the chlorides and the sulfates of calcium and magnesium. So the chloride and the sulfates of calcium and magnesium is removed from water. Then the permanent hardness of water is removed. So the main objective of this removal of permanent hardness, we want to remove the chlorides and sulfates of calcium and magnesium. And by doing this, we are taking so many methods. There are three methods. One is adding washing soda. Adding washing soda. So the first method that is adding washing soda. Add washing soda. And what is the formula for washing soda? Do you know that? This is sodium carbonate or bicarbonate. Listen, here sodium carbonate is a washing soda. So washing soda is nothing but sodium carbonate. So we are taking washing soda. Washing soda. So washing soda is nothing but sodium carbonate. That is Na2CO3, sodium carbonate. Okay. If you are taking sodium bicarbonate with carbonic acid, and it is baking soda. Remember. So by adding washing soda, the chlorides and the sulfates of calcium and magnesium is removed off as calcium and magnesium carbonate. So that the permanent hardness is due to calcium chloride or calcium sulfate or magnesium chloride or magnesium sulfate. So here we are taking a calcium chloride. So that is calcium chloride. That is CaCl2. Calcium chloride is added with washing soda. What is that washing soda? It is Na2CO3. Na2CO3. Then we may get what is the product? That is calcium carbonate and sodium chloride. So that here we are taking calcium carbonate CaCO3 and it is a precipitator. That is insoluble. It is insoluble salt. Insoluble salt. And the byproduct, that is 2NaC, 2NaCl, sodium chloride, and it is a soluble salt. But here we are getting the insoluble calcium carbonate, so that the calcium salts that will be removed and it will be filtered off. It will be filtered off. So the chemical which cause permanent hardness. Which are the chemical which cause permanent hardness? That is calcium chloride. The calcium chloride, which is a soluble. This is a soluble salt. Then it will be removed off, which is converted into a precipitate, that is insoluble salt as calcium carbonate. Then it is filtered off. It is filtered off. And here we are taking magnesium sulfate also. We are taking magnesium sulfate. Magnesium sulfate. So the sulfates or chloride will cause permanent hardness. So that it is adding with washing soda. What is the washing soda? That is Na2CO3. Na2CO3. Then what will happen? Here magnesium carbonate and the sodium sulfate. So here get magnesium carbonate. Magnesium carbonate that will be precipitated and the byproduct, that is sodium sulfate. Na2SO4. Sodium sulfate. So that here the magnesium carbonate, it is insoluble. It is insoluble. So it is insoluble salt, and this magnesium sulfate, which is a soluble salt. So the soluble salt is removed as an insoluble salt as carbonates. Okay, generally the carbonates are insoluble in water, but chlorides and sulfates are soluble in water, so that the soluble salts are removed as insoluble salt as carbonates. So that by adding washing soda, we may remove the permanent hardness. We may remove the permanent hardness. Okay, and we are there the second method. And in a second method, we are taking that is Kalgan process. What is that? Kalgan process. So we are taking the second method by adding Kalgan. What is that? Kalgan. Now, what is that Kalgan? And here, Kalgan is nothing but that is sodium hexametaphosphate. So we are taking a Kalgan. What is Kalgan? So Kalgan is nothing but sodium hexametaphosphate. So sodium hexa, that is 6 means hexametaphosphate. So sodium hexametaphosphate. Sodium hexametaphosphate. Sodium hexametaphosphate. Sodium hexametaphosphate. So this sodium hexametaphosphate, which is called as Kalgan. And sometimes this 6 is more than 1000 oxygen. We are using as a Kalgan. Okay. So here this Kalgan is written as, we will take this Kalgan. So this Kalgan may be written as, Kalgan may be written like this. What is it? Here we may take that is Na 2 times. And there is a complex of Na4. So there are 6 sodium. So the 6 sodium will be split into complex. And remaining, what is that? That is PO3 6 times. PO3 6 times. Why we are written like this? That means it will be forming a complex. It is a complex salt. So that this is a complex. So we are taking a complex of Kalgan. So it is a complex salt. A complex salt. A coordination salt. So the Kalgan, that is the sodium hexametaphosphate, is written as a complex salt. That is coordination salt. Now, this complex salt is reacted with the metal which is present in your water. It's present in your water, which cause the permanent hardness. So, what are the metals which cause the permanent hardness? Here, the metal salts are calcium and magnesium. So that here the calcium is reacted with this Kalgan, that is Na2, then Na4, PO3 6 times. So that it is sodium hexametaphosphate, and the sodium hexametaphosphate is reacted with the metal which is present in the water, which cause permanent hardness. Okay, so they are reacted together and form that is the insoluble complex. So the insoluble complex, it is Na2, and instead of sodium in a complex,
that will be replaced by calcium. So that here that is Ca2 and PO3 twice. PO3, sorry, it is 6 times. PO3 6 times and that is 4 Na plus. 4 Na plus. So that here we may take the calcium that will be present in a square bracket. Why we are taking a square bracket while writing a salt? That means in a square bracket, it is non-ionizable part. What is that? A square bracket represents non-ionizable part. It cannot be split. And so that outer shell of the square bracket, it is ionizable. So that here, this sodium is 2 sodium is ionizable. So this is ionizable and it is non-ionizable. So it is non-ionizable part. Non-ionizable part. So that it will be written in a square bracket. Non-ionizable part. So here calcium cannot be ionized in water. So that the permanent hardness is caused by this calcium ion that will be sequesterized. So that this process which is known as sequestration. What is that? Sequestration. So here ionizable part which contains this calcium ion, so that this process is known as sequestration. What is that? Sequestration. So what do you mean by sequestration? That means here the calcium, free calcium ion, this is free calcium ion, is present in a complex salt which is non-ionizable. So that the sequestering agent, what is the sequestering agent? Calgon is a sequestering agent. So here calgon is a sequestering agent, so that it will be sequester the calcium 2 plus ion. So the same way here the magnesium salt is also sequestered by calgon. So what is it? Here we are taking the magnesium salt instead of calcium. So listen, we are taking magnesium salt. So instead of calcium, we are taking the magnesium. That is magnesium plus. Then it is reacted with calgon. What is calgon? Sodium hexametaphosphate. So that it is sodium hexametaphosphate. So hexa means 6. So that sodium 6 times and the phosphate is also 6 times. So that Na4 and PO3 6 times. So that here magnesium is exchanged by the sodium ion. So we are getting Na2 instead of sodium, we are taking magnesium. So that is Mg twice and PO3 6 times. And 4 sodium ion is removed. So 4 moles of sodium ion. Sodium ion. So here sodium ion never causes the temporary or permanent hardness. Which one causes the temporary or permanent hardness? Only the calcium or magnesium or heavier metals. So only the heavier metals that will be cause the permanent hardness. So the permanent hardness is removed by, that is calgon. Permanent hardness is removed by calgon. So what are the methods we are using to remove the permanent hardness? The first method is we are taking caustic soda. And the second method we are taking is calgon. And the third method we are taking is ion exchange method. So we are taking the next method, it is ion exchange. So here the third method, ion exchange method. Ion exchange method. Ion exchange methods. So, in ion exchange method, there are two classes. Ion exchange method, there are two classes. One is cation exchange and the anion exchange. So, we may take that the cation. What is the cation? The positive ion, which is known as the cation, and the negative ion, which is known as anion. So, here the positive ions, that is Ca2 plus and Mg2 plus, which cause the hardness. So, it want to be removed to remove hardness, so that exchange of cation. And also, we may take that the negative ion. What are the negative ion? That is bicarbonate. So, the hardness which cause, suppose here we may write, that is hardness is caused by, listen, we are taking the hardness. Hardness is caused by the cation. What is the cation? It may be, what is that? Calcium and magnesium ions. So these are the cation which cause the hardness. And also that is the anion. So what is anion which cause the hardness? Here we are taking the anions. We are taking an anion. So what are the anion? Anion means they are negatively charged ion. So the anion which cause the hardness, one is bicarbonate, that is at CO3 minus, and another one, that is chlorides, and also that is sulfates, that is SO4 2 minus. So that here the cation and the anion which cause the hardness, So these are exchanged by some other. So instead of calcium and the magnesium cation, we may take the sodium ion, and the sodium ion never cause hardness. Then instead of this HCO3 minus and CO minus and SO4 minus, we may take some other OH minus, then it cannot cause us the hardness. So the hardness is removed by ion exchange method. And the first ion exchange method we are taking, that is inorganic cationic exchanger. So we are taking the inorganic cationic exchanger. So what are the cation here? Ca2 plus and Mg2 plus, that will be cause the permanent hardness that will be removed by some other method. So that here we are taking the inorganic. So this first method, it is inorganic cationic exchanger. Inorganic cationic exchanger. So this inorganic cationic exchanger is nothing but that is thermotic process, otherwise known as it is thermotic method. So in this thermotic method, we are using the inorganic cationic exchanger. So the inorganic cationic exchanger we are using here, that is known as zeolite. What is that? It is zeolite. So what is a zeolite? So here this sodium aluminosilicates. What is that? The sodium aluminosilicates are called as zeolites. So zeolites are sodium aluminosilicates. Sodium aluminosilicates. So the sodium aluminosilicates are called as zeolites. And here the example of zeolite, that is Na2 and Al2, SiO3, the X molecule of water. X molecule of water. So this sodium aluminum silicate is nothing but that is Na2, Al2, SiO3, X H2O. Okay, and for our convenience, it will be written that is Na2 set. So to make it simple, it will be written as that is Na2 set. Na2 set. And here, what is that? Set is equal to, that is Al2 SiO3 dot X molecule of water. So that here, for our convenience, to write it simple, we are taking Na2 set, and set is nothing but aluminosilicate. That is nothing but the aluminosilicates. So here this Na2Z is reacting with the cation. What are the cation? Calcium and the magnesium, and it will be replaced by sodium. So that this zeolite, this Na2Z, listen here, this Na2Z is Na2Z, that is a sodium zeolite, is reacted with calcium or magnesium. Maintain the calcium or magnesium present in water, which cause the permanent hardness, and it will be removed off as what is that? That is 2Na plus and that Ca set. So that here we are taking Ca set. Ca set, another that is 2Na plus. So the sodium aluminum silicate is converted into calcium aluminum silicate. So a sodium aluminum silicate is considered as a zeolite, and it is reacted with the calcium ion, which causes the permanent hardness, then it will be removed off by a zeolite, then it will be produces sodium ion, and the sodium ion never causes the hardness, so that the hardness of water that will be removed off. So that here we may take this in a diagram way, we are represent in this in a diagrammatically, we are taking that. Here, that is thermotic process. In this thermotic process, we may take here, listen. So, we are taking a thermotic process diagrammatic. So that we are taking here a larger iron tank. So, we may take a larger iron tank, and the bottom of the larger iron tank we may fill up with the porous sand. So here we may fill up with the porous sand. So that here we may fill up with the porous sands. So it is the porous sand. So it is a sand. Porous sand. And here we may take that the hard water that will be introduced in this porous sand. Now we will take that here we are filling with the permanent. So up to this level we may fill it with the permanent. What is that? The zeolite. What is a permutate? Permutate is nothing but zeolite. So the zeolite is filler. It is, and we may take that. We have taken the diagram here. We may take like this. And we are taking here, and here there is a soft water process. So we may take here there is a soft water collected here. So this is the soft water. So it is a soft water. So we may take a soft water pipe. So through this pipe, the soft water is collected. So the soft water is collected. So this is the soft water. Soft water. Then we are passing a hard water through the permutate. So we are taking the passing here. And the hard water is passed. So here the pass hard water. Hard water. So hard water is passed here, then it will be closed. So it is closed. And here also we are fitting another one pipe. And in this hole we have passed sodium chloride. Sodium chloride, that is 10% of sodium chloride. Now, listen. In this diagram, we are passing a hard water. Passing a hard water through that this permutate. And here, what will happen? The hard water entered. So the hard water is entered here. So the hard water will be entered like this in this pipe. Then what will happen? It is evaporated. So that this will be evaporated, or it will be moved up towards the upward direction. Towards the upward direction. So here the water, that is the hard water, is moved through the permutate, that is a zeolite. In permutate, what will happen? Here the calcium ion will be exchanged by the sodium ion. So what is the calcium ion? Which causes the permanent hardness in water. So the permanent hardness of water is caused by the calcium ion. So that what will happen? It is reacted with this permutate and it will become upwards. So here all the calcium ion is removed out here. All the calcium ion is removed out here, so that only the soft water that will be moved here. So we will collect here soft water. So here the soft water out. So we can collect the soft water. So soft water is produced here. So here a permanent zeolite is one. Here it will be reacted with the calcium or magnesium ion. Calcium or magnesium ion, and this a cation is exchanged by the zeolite. So now why we are adding that? This NaCl 10%. So here the permutate, after passing a hard water into permutate, what will happen? All the sodium ion is exchanged, so that permutate or the zeolite loses its property. So to regain the permutate, to regain the permutate, so we are there, regain the permutate, regain the permutate. We are adding the 10% of NaCl, so that this result we are taking adding of 10% of NaCl. So this CaZ is considered as MZ. So we are taking that is MZ. MZ. MZ is reacted with Na plus, that is sodium chloride 10%, then it will be become that is Ne, yeah, that is Ne2Z. So we are here, that is Na2Z. So Na2Z is nothing but that is a zeolite. So zeolite, what is that? We are taking a zeolite. So zeolite again regenerator. So by passing 10% of initial zeolite is again regenerator. So listen, here we are taking permanent hardness removal. So the hardness is caused by the cation, that is calcium or magnesium. It is considered as M. It is considered as M. So these are considered as M. It is considered as M. So the hardness caused by the cation is removed by zeolite. So zeolites are sodium aluminosilicate. By adding the sodium aluminosilicate, the calcium ion exchanges by the sodium ion, so that the hardness of water is removed. Hardness of water is removed. Okay. And the next method we may take that is organic exchanger. So we are taking organic exchanger. So we are taking organic exchange. Organic exchanger. And in this organic exchanger, we are taking the organic resins. We are using organic resins. Organic resins. And these organic resins are two types. One is acidic organic resins. That is acidic resins. Acidic organic resins. It is taken as organic so that it is R, and acidic so that it is H plus. So that here the organic, that means it contains R group, that is alkyl group. So RH plus, so R minus and that H plus, that is considered as acidic organic resins. Then basic organic resins. Basic organic resins. So we may take basic organic resins. So the basic organic resins are represented, that is R plus, and if it is a base, then it must be contains OH minus. So the basic organic resins, that is R plus OH minus, and acidic organic resins, that is RH plus. Now here, by using these organic resins, then we may remove the cation and also the cation. So how will you remove the cation? So we are taking removal of cation by these organic resins. So we are taking removal of cation removal of cation by organic resins. Removal of cation by organic resins. How to remove the cation by organic resins? What are the cation which cause the hardness? That is the Ca2 plus. Ca2 plus. And this Ca2 plus is reacted with the RH plus, so that RH plus and the R minus. Then what will happen? We may get it. That is CaR2, and that H plus. CaR2 and that is 2H plus. 2H plus. So there is 2 molecules of organic resins.
So here the calcium ion is removed by the acidic organic resin, so that this is acidic exchanger. Then removal of anion by this organic resin. So we are taking the next one. It is removal of anion. Removal of anion by organic resins. Removal of anion by organic resins. And in this case, what will happen? Here, in this case, we are taking that is ROH. So we are taking the anion. So what is the anion here? That is Cl minus. Cl minus is reacted with ROH. So R plus and then OH minus. So we are getting that is RCl and that OH minus. So here we may take we are removing both the cation and the anion, so that in this method we is used to get that is demineralized water. So ionic resins are used. Ionic resins are used to get demineralized water. So what is the use of this method? Is demineralized water. Demineralized water. So the demineralized water we are getting by this way. So here, listen students, in this session we are taking so many classes. That is hardness of water. So listen, we may conclude here and I am asking some questions. Correct? So here we are getting hard water and soft water. Okay. Hard water and that soft water. How many of you are present? 122 members. Listen. Why we may take hard water and soft water? Hard water and soft water classification is based on
leather forming ability of water with soap.
So, due to leather forming ability, which one is considered as soft water? Which one is considered as soft water? Why?
Also free.
Forms leather easily are called as
Soft water.
Okay. What do you mean by soap? What is the formula for soap?
2RCOONA.
RCOONA.
Okay. RCONA. What is actually soap? It is fatty sodium salts are
Fatty acid.
Fatty acids.
the sodium salt of fatty acid as nothing but soap. Okay. And what are the chemicals which cause the temporary hardness?
Due to calcium and magnesium bicarbonates.
Very good. Okay. So temporary hardness is caused by calcium and magnesium
Bicarbonate.
And permanent hardness is caused by
Presence of soluble salts
Presence
of magnesium and calcium.
magnesium.
calcium, magnesium,
Magnesium and calcium chloride. Magnesium and calcium. And calcium sulfide.
Due to the presence of soluble salts of
Chloride and sulfates of
Sulfate.
magnesium and calcium.
Isn't it is sulfide or sulfate?
the sulfate.
Sulfates.
Sulfate.
What is the sulfate radical? Formula for sulfate radical? Formula for sulfate radical.
4 minutes.
Yes.
SO4 2
SO4 2 minus.
2 minus.
Sulfide radical. Sulfide means it is listen. Sulfide S2 minus. Sulfur is nothing but sulfide. S2 minus is nothing but sulfide. SO4 2 minus is nothing but
sulfate.
and so the permanent hardness is otherwise known as permanent hardness is otherwise known as
Non-carbonate
Non-carbonate hardness.
non-carbonate hardness.
Hardness.
Okay. So the temporary hardness.
Carbonate hardness.
Carbonate hardness.
Carbonate hardness.
And jump into the next question. How will you remove the temporary hardness? What are the process?
By boiling.
Boiling.
And the slab.
Pressure.
By boiling. Very good. The second one,
Class method.
process.
Clark's method. Clark's method.
Clark process.
and what is the chemical used in Clark process?
Lime,
By adding lime.
What is the formula for lime?
CaOH twice.
H2.
CaOH twice.
Twice.
Calcium hydroxide.
Do you know quick lime? Quick lime. What is that? Quick lime means calcium oxide. CaO is quick lime. Okay. CaOH twice is lime water. So in this Clark process, we are using lime water. Okay. In this Clark process, what happens when excess of calcium hydroxide or lime is utilized?
So which gives calcium bicarbonate.
Calcium bicarbonate, which caused the temporary hardness again. Correct? Very good. Why is this? Same again.
The Idigos.
What is that?
The Idigos.
People. Okay, good. Very good. So, here, excess of calcium hydroxide is not utilized for that is Clark's process. Because again, it will be from calcium bicarbonate. Okay. What are the method used to remove permanent hardness?
Adding washing soda by
adding
carbon.
wash,
Ion exchange method.
Washing
Ion exchange method.
Diagon method.
washing soda and argon and that.
Ion
Diagon
exchange method.
Ion exchange method.
What is the formula for washing?
Na2CO3.
Sodium carbonate, sir.
sodium carbonate.
Carbonate, sir.
Sir, I can't hear your voice clearly, sir.
What is that?
It's not clear.
Oh, voice is not clear.
Yes, sir.
Okay. Now?
Yes, sir.
Okay. Now, what is the formula for washing soda?
Sodium carbonate, sir.
Sodium carbonate.
CO3.
Carbonate. Na2CO3.
Sodium carbonate.
Carbonate.
Okay. Baking soda?
NaHCO3.
NaHCO3.
Only with NaHCO3?
The sodium bicarbonate.
Sodium bicarbonate.
Sodium bicarbonate and tartaric acid. Tartaric acid. What the sources of tartaric acid? So sodium bicarbonate and tartaric acid is nothing but baking soda. Okay. What is Kalga?
Sodium hexametaphosphate.
So sodium
hexametaphosphate.
Hexametaphosphate is nothing but Kalga. Okay, very good. So, what is zeolite?
Sodium aluminosilicate.
Sodium
Aluminosilicate.
used for cationic exchange or anionic exchange.
Cation.
So zeolite is used for cationic exchange. Okay. And organic ion exchanger. Give an example. Organic ion exchanger. Organic ion exchangers are organic resins. Organic resins.
Resins.
And if you are using organic resins, cation is removed or anion is removed or both are removed.
Both are.
Both are removed.
Both are.
What is deionized water? What is deionized water?
So ions are removed.
Ions are removed. What are the ions are removed? Cation or anion or both? So deionized deionized water is one both cation and also anion is removed. It is known as demineralized water. Demineralized water. Okay. Okay, students. Thank you. And so
Thank you, sir.
Thank you, sir.
is not in your book. Calculus process is not in your book. Only in your book, adding washing soda, Planck's process, and boiling are there. And also permutic method is there in your book, but organic resins is not in your book. So take a notes. Okay, thank you. Thank you.
Thank you, sir.
Thank you, sir.
Thank you,
Thank
sir.
you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.